Greetings and namaskar to each one who came here to watch this video.
Now let's take more complex question. So here in this question, we have 4 resistance this side, one is grounded and the other one is used as feedback. We have to find out the output voltage, that is this V0. So now let's mark current, voltages and the points. So starting with point, let us mark this point as A and this point as B. Let this be I1, this be I2 and this be I3, and let this be I4 and this be I5, and this outgoing current, let it be I6. What about voltage? Again, let's assume this unknown voltage as Vx, and similarly this is also Vx. Now firstly we will solve for point B. From here we will get the value of Vx, and using it while solving for A, we will get the value of V0. This is what we need. So let's start. So at point B, here I1 plus I2 is equals to I3. The incoming current is equals to outgoing current. So I1 plus I2 is equals to I3. Now the voltage on the current I1 is 4 minus Vx. 4 minus Vx divided by its resistance, that is 40, plus 5 minus Vx divided by 50 is equals to Vx minus 0, because it is grounded. So Vx minus 0 divided by 30 volts, that is 30. So let's solve it further. You can cancel all the zeros. Now let's solve it. 4 divided by 4 is 1. So it's 1 minus Vx divided by 4. Similarly here 5 divided by 5 is 1 minus Vx divided by 5 is equals to Vx divided by 3. So 1 plus 1 is 2. Let's carry all the Vx terms to the right hand side. Taking Vx common, we can write 1 divided by 3 plus 1 divided by 4 plus 1 divided by 5 and Vx. Taking LCM and solving it, we get 60, 20 plus 15 plus 12 and Vx here. So we will finally get Vx is equals to 120 divided by 47. So this is we get the value of Vx. Now let's solve for point A. So at point A, the incoming currents are I4 plus I5, which is equals to I6. I4 plus I5 is equals to I6. So I4 plus I5 is equals to I6. So 2 minus Vx for I4, 3 minus Vx for I5 and Vx minus V0 for I6. So let's write it. 2 minus Vx divided by its resistance, that is 20, plus 3 minus Vx divided by 30, its resistance, is equals to Vx minus V naught, and its resistance is 60 volt, so 60. Let's solve it. Cancel out 0. Again following the same process, 2 divided by 2 is 1. So 1 minus Vx divided by 2 plus 1 minus Vx divided by 3 is equals to Vx divided by 6 minus V naught divided by 6. 1 plus 1, 2. And let's take this minus V naught by 6 to the left hand side and rest terms to the right hand side. So we get V naught by 6 is equals to minus 2 plus, taking Vx common, so Vx 1 by 2 plus 1 by 3 plus 1 by 6. Now let's solve it and put the value of Vx from here, that is 120 by 47. So minus 2 plus 120 by 47 into 6, and taking this 6 to this side, so we will write this will become 12 and 6 multiplied by this, and this value will give 1. So here we multiply only 6 with this Vx value. Finally we will get 156 divided by 47, which is equals to 3.3 volt. That we will get V naught is equals to 3.3 volt. So this is it, and we get the output voltage. So now let's level up our questions and let's move to different kind of question. Alright, so here the question is, what is range of gain? It is asking the range of the gain. So here you can see in the figure, this is a symbol of variable resistance. It is also represented as this. So this will vary till when? Till 10k. So what can be the minimum value? Obviously 0, and the maximum value, it is given 10 kilo ohm. So this variable resistance can vary from 0 to 10 kilo ohm. So let's solve this problem by assuming, for now let's assume this variable resistance as R, because it can vary and can have any value between 0 to 10. That's why we have taken it as R. Now see, these two resistance are in series. So simply adding them, we will be writing it as 15 plus R, and let this point be A. And as this is grounded, means it is 0. So from the concept of virtual ground, the voltage over here will also be 0. And let this incoming current be I1, and the outgoing current here, it is I2. So here we are done with necessary marking. Let's solve this question. Let's first take this point A. At point A, I1 is equals to I2. I1 is equals to I2. Now Vi minus 0. This Vi is input voltage and this V naught is output voltage. So Vi minus 0 divided by, as I told you, these two resistance are in series, so we're gonna add them. 15 plus R is equals to 0 minus V naught divided by its resistance, that is 50 kilo ohm, so 50. Let us convert it in the form of V naught by Vi. This V naught and this Vi. So V naught upon Vi, and solving the rest term, taking this 50 this side, we will get 50 divided by 15 plus R. and that of negative sign. Because we have this V naught as negative, so moving it to the other side, this value will get a negative sign on it. So here we get V naught by Vi. Now this V naught by Vi is the voltage gain, that is written by AV. So this can also be written as AV. This is voltage gain. Let me write here where AV is voltage gain. Now what to do? The question is asking the range. So one by one we are going to put the value of this R. You can see this R. We will put the minimum value, that is 0, and then we will put maximum value, that is 10 kilo ohm. So at R is equals to 0, this AV is equals to minus 50 divided by 15 plus 0. This is equals to minus 3.33. Alright, now at R is equals to 10 kilo ohm, then AV is equals to minus 50 divided by 15 plus 10. This will give us the value minus 2. So here we get the range, that is from minus 3.33 to minus 2. But here you have to remember that gain is always represented in mod, which means the values will be positive always. Therefore, it will be written as 2 mod of voltage gain to 3.33. So here we get the answer. It is the range of gain. Now let's move to the next question. So here in this question we have to find range of output, that is we have to find the range of this V naught, and again you can see this symbol of variable resistance. So let's again take it as R and let this point be A. It's given that it is 1 volt, so by the concept of virtual ground this is also 1 volt. And let's mark the current, let it be I1 and this outgoing be I2. So now let's solve it for the range of output. Now let's take this point A. So at point A, I1 is equals to I2. So here it is grounded, so 0 minus 1 volt divided by, as you can see these resistance are in series, so again 10 plus R is equals to 1 volt minus V naught. So 1 minus V naught divided by the resistance here 40 kilo ohm, so 40. So let's solve it. So it's minus 40 divided by 10 plus R is equals to 1 minus V naught. Taking V naught this side, then 1 plus 40 divided by 10 plus R. So let's solve this. So here we get the output voltage. Now what we are going to do? We are going to put the value of R. Firstly, we will put the minimum value, that is 0, and secondly the maximum, that is 10 kilo ohm. So let's go. At R equals to 0, V naught is equals to 1 plus 40 divided by 10 plus 0. This is equals to 40 by 10 plus 1, that is 4 plus 1, 5. And if we take R is equals to 10, then V naught is equals to 1 plus 40 divided by 10 plus 10, that is 20. 40 divided by 20 is 2. So 1 plus 2 is 3. So this is the range of the output. So we can write it as 3 volt to 5 volt. So here we get the range of the output voltage, that is 3 to 5 volt. So here in this question, it is given that if V0 upon Vi, that is V output divided by V input, is equals to minus 10 volt, then value of R is. So here, as you can see in this figure, we have to find the value of this R, and V0 by Vi is given as minus 10 volt. So by using this, we have to find the value of R. So let's start. First mark the point. Say this point as A and this point as B. And as you can see, this is grounded. It means it is having 0 volt. And with the concept of virtual ground, this is also 0 volt. So 0. The voltage at B, let us say it is Vx. Now talking about current, let this entering current be I1 and this outgoing current be I2. And further, let this current be I3. This is entering and this is dividing into 2, that is I3, and let this side be I4. So now let's start. Let's first solve it for point A. So at point A, I1 is equals to I2. Vi minus 0 for I1 divided by the resistance, that is 100 kilo ohm. So 100, which is equals to for I2 0 minus Vx divided by its resistance, that is R. So R. So from here, after solving, we will get Vx is equals to minus R divided by 100 Vi. So we get Vx from here. Now let's solve it for point B. So at point B, I2 is equals to I3 plus I4. So I2 is equals to I3 plus I4. So for I2, 0 minus Vx divided by R is equals to, for I3, Vx minus 0, as it is grounded. So Vx minus 0 divided by 100, its resistance, plus for I4 it is Vx minus V0 divided by again 100. So rewriting this, so from here we get, taking 100 common and multiplying that side, so we get minus 100 by R, Vx, and twice of Vx here, minus V0. So now let's take this V0 to the left hand side and the rest term to the right hand side. So we get V0 is equals to twice of Vx plus 100 divided by R Vx. So it is 2 plus 100 divided by R Vx. And now we can put the value of Vx from here, that is minus R upon 100 Vi. So let's use it here. It is 2 plus 100 divided by R minus R Vi upon 100. So we can write it as V naught divided by Vi is equals to minus this minus 2R plus 100 divided by 100. So from here, so now it's time to apply the value of V naught upon Vi that is given in the question. It is equals to minus 10 volt. So now we can write minus 10 this side. So minus 10 is equals to minus 2R plus 100 divided by 100. Now cancel the negative sign from both sides. 1000 is equals to 2R plus 100. That gives us twice of R is equals to 900. And from here R is equals to 450 kilo ohm. This is because each and every unit is given in kilo ohm. So our resistance will also be written in unit of kilo ohm. So this is our final answer. We found the value of R. So as you can see, each kind of questions, maybe they are asking us to find out the range, or they are asking for current, output voltage, resistance, whatever. Each and every question, we are able to solve it with the simple concept of the Kirchhoff's law, that is incoming current is equals to outgoing current. This is the simplest method to approach any question. So now let's move to the next question. So here in this question, if V0 is equals to minus V1 plus V2 divided by 2, then we have to find out the value of R1 divided by R2. We have given the value of V0 and we have to find the ratio of R1 to R2. So again, by using the same concept, putting incoming current to the outgoing current, so let's first mark the points. So let this point be A and this point be B. Let the voltage at this side be Vx. So similarly, it will also be Vx. Now talking about current, let it be I1, the incoming current, and the outgoing current be I2. Similarly, this way, let this current be I3. Current going this way is I4. So this is it. Let's begin with solving point B. From here, we will get the value of Vx and then we will proceed with point A, and this way we will be able to reach to our result. So let's see how it goes. So starting with point B. So at point B, I3 is equals to I4. So for I3, V2 minus Vx divided by R1 is equals to, for I4, we have Vx minus 0 and resistance is R2. So let's divide V2 divided by R1 minus Vx divided by R1 is equals to Vx divided by R2. Now let's take this Vx term to the right hand side. We get V2 upon R1 is equals to, let us take Vx common, so Vx 1 by R1 plus 1 upon R2. And now taking Vx to the left hand side, so here by solving this we will get the value R2, V2 divided by R1 plus R2. Now let's move to solve point A. So at point A, I1 is equals to I2. So V1 minus Vx divided by R is equals to Vx minus V0 divided by R. Now cancel the R from both sides and we will get V1 minus Vx is equals to Vx minus V0. From here, let's take V0 to the left hand side. So V0 is equals to twice of Vx minus V1, which is equals to, let's write minus V1 plus twice of Vx. Let's use this value of Vx over here with multiplying it by 2. So twice of R2 divided by R1 plus R2 and V2. So now this is what we get, which is equals to V0. Now what we are going to do, we are going to compare. As you can see in the question, we have given the value of V0. So we are going to compare this value of V0 to this value of V0. So let's compare it. So now for comparing the values of V0, let's take this part on the left hand side, that is minus V1 plus twice of R2 divided by R1 plus R2 multiplied by V2, which is equals to this value which is given in the question, that is minus V1 plus V2 by 2, minus V1 plus V2 by 2. So from here you can see we can cancel this minus V1 to this minus V1. Similarly V2 by V2. So 2 times 2 is 4. So here 4 R2, and taking this denominator to the right hand side, so it will become R1 plus R2 here. And from here 4R2 minus R2, that is 3R2. So 3R2 is equals to R1. From here we have to find the value of R1 by R2. So R1 divided by R2. We are taking this R2 on the right hand side. So we get 3. So the ratio of R1 by R2 is 3. So this is it.
Hope you found this video productive. Thanks for giving your time here. Take care.